Again, we'll go over our quick overview of purge and trap, our common method types and their challenges, how to select our best equipment, consumables considerations, and then we'll tie it all together at the end. So let's start this slide over. So how purge and trap works. So the theory of purging and sweeping a sample with an inert gas is called the dynamic headspace theory. It sounds simple, but it's a very complex process. Purging a sample to extract analytes is a gas extraction. In purging a sample, the system is no longer at an equilibrium. And this is because the VOCs that move into the gaseous phase are constantly being removed by the purge gas. Continuously replacing that headspace causes a disequilibrium in that there's always a higher concentration of VOCs in the liquid phase than in the gaseous phase, creating a net movement of VOCs from liquid to gas, extracting the VOCs from the sample more efficiently and improving on sensitivity. Then the gas is swept away onto the trap where it is then concentrated and released to the GC. So a basic purge and trap consists of 5 main parts: sparger, flow control, 6-port valve, the analytical trap, and the heated transfer line. The sparger is the glassware on the front of the instrument that receives the liquid sample to be purged. Purging the sample extracts the VOCs by dispersing the inert gas through the sample matrix for a preset time and flow. The flow is controlled by a mass flow controller or a pressure regulator that monitors and precisely controls the gas flow rates throughout the entire purge and trap process. From there, the 6-port valve directs the gas containing the analytes to the analytical trap for concentration. By backflushing that carrier gas through the analytical trap, the 6-port valve directs the VOCs to the GC for separation and detection. The analytical trap is used to capture and release VOCs swept out of the sample by the purge gas. So trapping these VOCs helps create a smaller band of analytes traveling to the GC column, producing greater signal-to-noise ratios, lower area-to-height ratios, and it generates sharper peaks and better sensitivity and resolution. So once the VOCs are captured, the trap is heated, causing the VOCs to desorb, and then carrier gas is used to desorb those VOCs off the analytical trap and carry them through the heated transfer line to the GC. So Teledyne Tekmar is the market leader for purge and traps in our nation, and we offer several different options. The Lumen Purge and Trap Concentrator, which is shown on your right, it's a standalone waters-only concentrator that can be paired with the Aquatech LVA autosampler. And we also have the combined autosampler purge and trap concentrator, the Atomicsxyz, shown on your left, and that's capable of analyzing soils, solids, and water samples. Purge and trap methods can be broken down into 2 major categories: water methods that can be further broken down into drinking water and wastewater with in-vial purge and traditional sparger purging, and soil and solids methods that can be further broken down into low-level samples, which are typically purged directly in the sample vial, and high-level samples, which need to be diluted through methanol extraction. For most of our customers, these methods are regulated by governing bodies, whether at the federal or the state government level. All of these methods cover sample collection, preservation, transportation, analysis, and even data handling. This will include specific instructions or considerations for purge times and flows, tuning requirements in the mass spec, and much, much more. Now let's go over some of the challenges that come with purge and trap workflow. We will start at the beginning with sample collection. Vial cleanliness can sometimes be a challenge. If there are any volatile compounds already in the vial, that can lead to contamination, and false positives for our customers, which can be really frustrating to identify. Especially, say you're a contract lab and you may receive outside samples and you don't know the quality of those vials used for collection. Generally, the solution to this is to use certified pre-cleaned vials, or in cases when those aren't available, vials should be cleaned with soap and water and then baked to remove any volatiles. Sample transportation. Keeping those samples cold is always a challenge that we've seen for customers. Once they are collected, they need to be kept on ice, dry ice or ice packs in a cooler, and whether those samples and whatever is used to keep those samples cold should last the duration of the transportation of that sample. Then once they're in the lab, they need to be kept cold in the refrigerator, and depending on the method that you're using, some samples need to be chilled on the auto sampler as well. And Tekmar offers auto samplers with chiller plates to meet those method requirements. Moving on to the challenges associated with the analysis of these samples. So many of these regulatory methods were written 10, 20 years ago. Therefore, the techniques and equipment used when the methods were written were very cutting edge at the time, but now they're pretty out of date by our standards today. Therefore, these methods are known for long run times or for detuning the mass spec, therefore not allowing the system to run as fast and as sensitive as they otherwise could be. So just to look at a few examples of this. So typical methods will lay out purge, desorb, and bake times, which can easily add up to 15 to 20 minutes of your sample cycle times for those methods with just these 3 parameters. So this is not including the other steps of the process that we have. So it could take at least 20 minutes of runtime total, including sample preparation. And sometimes it could last even longer, up to 30 minutes per sample for these methods like 524.2 or 8260. You compare that to typical GCs today that can turn out a full list of 80 to 90 volatile compounds with good separation and detection in a 15-minute cycle time. So that's from injection to injection. A newer, more updated method like 524.3 allows for more flexibility with less restrictive times for parameters. So you would be able to get those sample cycle times a lot lower. Other challenges include water vapor. The purge and trap introduces a tremendous amount of water vapor to the GCMS. So what are our solutions to help us with this? So Tekmar's moisture control system and our application control within our software help. So letting dry gas flow through the trap during the purge phase and shortening desorb times reduce moisture. Our research shows that the compounds of interest that we want to see are out within 2 minutes, and in some cases as soon as 1 minute or 30 seconds of desorption. That amount of time will give us enough compound transfer to the GC to give us the kind of sensitivity that we need. So anything beyond that 1 to 2 minutes of desorb is only introducing more water vapor into the system. So by shortening that desorb time, we can significantly reduce the amount of moisture introduced to the GC. Beyond moisture considerations, which are applied to all method types, what are some of the challenges that we run into when dealing with different methods? So each of these method types listed have their own set of challenges. With drinking water, customers deal with low-level sensitivity. During wastewater analysis, typically customers are dealing with carryover contamination in the system. We have to make sure that we have adequate cleanup between samples and linearity over a dynamic range, because you have some samples that might be very high in concentration and that could be the total opposite for the next sample. Many specialty methods that apply purge and trap aren't always best suited for purge and trap, so they bring their own set of challenges to purge efficiency and low-level sensitivity, such as mold and odor analysis and 1,4-dioxane. With drinking water methods, low-level sensitivity is the primary challenge. So routine maintenance, like making sure the trap is clean and replaced on a regular basis, making sure that the sparger is clean, replacing the rinse water regularly to prevent any buildup of those volatiles that could be in the lab air. All of these things can keep the sensitivity nice and low and your MDLs low. Tekmar's improved moisture control fitting on the Atomicsxyz and the Lumen, and possibly adding some more dry purge time into your purge and trap method can be particularly important for drinking water analysis. So for all those front-end compounds that co-elude with the water peak, the less water there is, the sharper those peaks will be, and the more consistent their retention times will be. Keeping desorb times short and the split ratios high can also help manage the water and keep the front end looking good. With wastewater methods, carryover and contamination are the primary challenges. So for example, if you have a sample that is a benzene concentration of 200 ppb, and that's followed by a sample with no concentration of benzene, even a carryover of 1% would be 2 ppb, and that's easily identifiable in a purge and trap analysis and could cause a false positive. So not only do we need to keep up with routine maintenance, such as trap and sparger maintenance, but also mass spec source cleaning, GC column trimming, and inlet maintenance. And most importantly, how we are cleaning up the system between these samples. All of our products offer water heaters that can heat up the water to 90 degrees Celsius and can do up to 3 rinses. Additionally, if a sample is a sludge or is oily, methanol rinsing can help to remove those sources of carryover and help clean up the sample, like between samples. Just as important for wastewater analysis are active sites in the gas pathway. Wastewater samples tend to be a more complex matrix, like a combination of solids or particulates and volatile compounds, which we're interested in, but also some could be semi-volatile compounds. And that could be in the sample, and that can build up over time in the gas pathway as they are purged out of solution and then deposited inside of the purge and trap system. So as these start to build up in the gas pathway, the parts of the system that we don't normally consider to be consumables can cause active sites where reactions can occur and can serve as absorbents, where some of the compounds of interest will get stuck or hung up and could be re-released into the next sample or samples after that, or may just disappear altogether and we see a suppression of the actual concentration being passed on to the detector. So the only real option here is to pre-screen our samples to figure out what we're getting ourselves into as far as concentration and dilute the sample if needed. But also, just so we know, how often we need to clean and maintain our system. If those samples are really dirty, obviously we need to clean and maintain our system more often and replace our consumables as necessary. These mold and odor compounds are broader. They're more like semi-volatile compounds. They're large and sticky molecules that are hard to purge, and the solutions that we have here are using a 25 mil sparger instead of the standard 5 mil sparger. The larger sample volume and applying heat with the help of a sparge vessel heater will help to drive those compounds out of the water phase and into the gas phase. Not only are they big and heavy, but once they are on the trap, they can be hard to re-release. And they can cause carryover, trap fouling, and back pressure issues. Therefore, we recommend a 10X trap to aid in the re-release of these compounds, specifically the 1A trap for its large mesh size, and that large mesh size helps resist fouling and back pressure issues a little bit longer than a standard 10X trap. Recently, I've had some luck with a K trap, but it really depends on how often and how many samples you're running with this specialty method. And 1,4-dioxane is challenging because it's a poor purger. But in this case, it has more to do with it being hydrophilic. So some of the same solutions apply here. We need to use a larger sample volume with the 25 mil sparger and applying heat with that sample vessel heater. That can help boost the sample's sensitivity, and looking at sim mode on the mass spec can also help improve the low level sensitivity. And in this case, unlike the mold and odor, it's more of a traditional compound in the sense that you can use the K or the number 9 trap with good success. And we don't have to use a specialty trap for this method. So what about all of the other challenges that we've talked about so far? So like long sample times due to method requirements. How do we shorten those run times as much as possible? At Tekmar, we focus our designs on shortening all of those other time periods that we can have control over. Times that are not regulated by the method and won't affect results for our customers. A good example of this is if we bake the trap at 280 degrees Celsius and then we need to cool that down back to room temperature before the next sample starts to purge onto the trap. The shorter that time period is, the better. So we've improved our purge and trap design to cool down the trap as fast as possible between samples. The same thing when heating up the trap to reach desorb temp. The faster that we can get there, the better, and the more time that we can give back to the customer for sample throughput and analysis. We have focused a large amount of our effort on improvements to our moisture control. The more water vapor that we can remove through mechanical means, the less dry purge time that you need to use. So in our Atomicsxyz and Lumen, the moisture management is so efficient that we can reduce or eliminate the need for dry purge altogether. And that can get the customer anywhere from 1 to 5 minutes of time back. So it ends up saving a lot of time. Other things that we can look at for controlling that moisture, not through the hardware that we have designed, but through smart method parameters on the GC side. And that can help you get some time back too. So by using shorter, narrow bore GC columns that allow for higher split ratios, and that not only allows us to push a lot of that water vapor off through the split, but also increases the flow rate through the trap during desorption, allowing us to shorten that desorb time and further eliminate water. So how can we tie all this together into a package for our customers? Generally speaking, we can divide these into 2 categories, so our drinking water and then our wastewater soils. So if you're interested in drinking water analysis, are you looking for a traditional sparger purge or an in-vial purge? do you need to chill your sample on the auto sampler during analysis, or is that something your method doesn't require? On the wastewater side, do you need in-vial purge capabilities for soils? If not, do you need to auto dilute your sample, or do you need methanol extraction capabilities? Or if that's not necessary all the time, do you prefer to do those on the bench? So for drinking water, the Lumen and the Aquatech LVA were specifically designed for these methods. The chiller plate is built in. It's a standard feature. The Lumen is and the Aquatech LVA, it's a loop and valve system, so no syringe that needs to be replaced as it wears out. There aren't any dilutions capabilities, but it's a simple, robust, fewer consumables, really directed towards the drinking water market. And the Atomicsxyz works just as well. We do offer a chiller plate as an upgrade. So if you run a lot of drinking water samples, but have the possibility or interest in running other applications, the all-in-one Atomicsxyz might be for you. And on the wastewater side, the Atomicsxyz was specifically designed for wastewater's soils and sludges methods. It has all the features: in-vial purge, dilutions, and methanol extraction capabilities. And we do offer foam elimination upgrades. So if foam is a concern, be sure to consider a fritless sparger as well. However, the Lumen and Aquatech LVA can also serve for wastewater customers, in particular those who don't need in-vial purging. So say you're not doing any types of soils or solids and you don't expect the need to do any auto dilutions. So either you know your samples are going to be low in concentration, say it's an industrial application and you just want to pre-screen your samples before discharge to a municipal wastewater, or maybe it is a wastewater facility that knows that their samples are well within the calibration range and you prefer to, or if you prefer to dilute on the benchtop, then the Lumen and Aquatech LVA might just be for you. So I just want to thank you for taking the time to join me today, and please check out our website for all of our latest application notes and to visit our online store. You can follow us on social media as well. And it looks like we have a few minutes for questions. Let's see. All right, and I have one. How do you know when you need to replace your trap? So if you have a Tekmar product in our software, you can go back into the sample history, and when you start to notice that the purge and bake pressure from your sample, from sample to sample, keeps increasing very fast, then it's time to replace your trap because the sorbent material is starting to break down. You know, compounds that they start to cause problems would be like artifact peaks of benzene or toluene in your blanks. And you'll start to notice if like 2-cleave has less of the response. That's when you know when to replace your trap. So I have another question. What is the best way to clean the lines if you suspect active sites? So unfortunately for like the gas pathway, all of those lines have to be replaced. But if you do have heavier samples, soils, solids, sludges, you can do methanol rinsing between samples. So that can really help, especially with carryover, any kind of carryover issues. If you have any samples that I would say are a larger concentration than 200 ppb, then I would definitely do some methanol rinsing just to help prevent those active sites from starting in the gas pathway. And that looks like all the questions we have. So thank you so much for joining me today.